Okay. Yes. Okay. So first we'll study about ion dipole interaction. Better? Ion dipole interaction. Okay, as I said earlier, what's ion dipole interaction? The interaction between an ion and a dipole. Dipole means polar molecule. Right? A polar molecule, right? Oh, ion dipole interaction. Ion and a dipole, right? Okay. You know, mostly ionic compounds are, right? Ionic compounds are normally soluble in water. Why? Soluble means what? Actually, mixing. Right? Mixing. Ionic compounds are solids. Water is a liquid, and when you dissolve ionic compounds, that means that solid ionic solids, what will happen? They will mix with water. They will completely mix with water and form a homogeneous solution. Right? Homogeneous solution. Right? Okay. What's the meaning of homogeneous? Homogeneous means, yeah, uniform throughout everywhere. Right? Uniform. Right? If you dissolve sodium chloride in water, the solution would be homogeneous because all part of the solution will be same. Right? No difference. Right? Completely same. Right? But if you dissolve the flour or something, right? It is partially soluble or insoluble, right? So the mixture would be homogeneous or heterogeneous. Heterogeneous, right? Right? There are some portion like this, right? Yeah, if you dissolve soil in water, a small portion of soil is soluble. So this solution, only this right on, this is soil, insoluble soil, that it will be settled. Yeah, it will be settled down. Insoluble solid soil will be settled down, and this its solution, a small portion of soil will dissolve. So this portion is homogeneous but totally heterogeneous. There are two phases, right? Okay, so this is what this total mixture is, heterogeneous. Okay, we'll study that later in unit 11, oh sorry, unit 12, homogeneity, heterogeneity, unit 12. Okay, next. So what happens if you dissolve sodium chloride? It will dissolve and form a homogeneous solution. How it dissolves? If any two metals or two things mix together, what will happen there? Attraction. There should be an attraction, and because of attraction only, the two portions will mix. There should be an attraction, right? So what's the attraction? Sodium chloride. What are there in sodium chloride? Ions, Na plus ion and Cl minus ion. Water means what? Water is a polar molecule. Then dipole. Water is a dipole. Polar molecules are referred to as dipole, permanent dipole. Right? Okay. So there will be an attraction between this ion and dipole, polar molecule, water. Water is a permanent dipole molecule, right? The attraction is called ion dipole attraction, right? It is called ion dipole attraction, right? So, if it is also sodium chloride, what will happen? Na plus Cl minus, right? Okay. Okay. Around Na plus, water molecule will be surrounded like this, and around Cl minus, water molecule surround like this. Right? Why? You know, this part is delta minus, these two are delta plus. Oxygen is delta minus. So Na plus should attach to what? This is plus. So delta minus, right? The delta minus in dipole form bonds of attraction with Na plus. What about there? Cl minus, so delta plus. Right? This delta. Okay. And because of this attraction, because of this ion dipole attraction, sodium chloride will initially dissociate as Na plus and Cl minus, right? Initial dissociate as, right, in solid state, Na plus and Cl minus will be like this: Na plus Cl minus, Na plus Cl minus, like this, because it's an ionic compound, right? Cl minus, Na plus. So, you know, 6 chloride around Na plus, 6 Na plus around chloride. You have studied, right? Now, what will happen next? How these Na plus and Cl minus get dissociated or separated? Yeah. Oxygen round up Na plus. Right? The water molecules round up Na plus using this ion dipole attraction, and chloride is also round up. So they will dissociate because they each ions are round up with water molecule. This process is called hydration, right? Round up with water molecule, that is called hydration, right? If you use water as a solvent, then it is called hydration. If you use any other solvent, that process is called solvation. So solvation is a common. If the solvent is water, then it is specially known as hydration. Solvent, right? Solvation is a common word, right? Okay. That's all. Then Na plus and Cl minus will be separated, and water molecule is normally, you know, it's mobile. Water molecule is mobile, it always moves. Now Na plus is round up with water molecules, and these water molecules as usual moves. So Na plus also move with that water molecules, this group of water molecules, right? Okay. So sodium chloride will become liquid. That means Na plus and Cl minus are able to move now, right? Able to move now because they are mixed with water molecules and separate, right? Well separate with Na plus and Cl minus is well separated, right? Well separated. So there is no attraction between Na plus and Cl minus. Okay, no attraction. Well separated, round up by water molecule, right? again, one important thing, it's just for general knowledge. Can you tell which bond is stronger? This ion dipole attraction, this new ion dipole attraction, or this ionic bond? Which one is stronger? This ion dipole attraction or ionic bond? Ionic bond is very much stronger. Why? It's a primary interaction. Primary interactions are always much more stronger than secondary interaction. Primary interactions are very strong. So this is very strong compared to this. So what's the next question? What's the problem? What's the problem you should have? So how these can be dissociated? Whether this bond this bond is broken and a new bond is formed. It's not possible. Why? It's very strong, very weak. So how this weak? Why this dissociated? Because of this attraction. This attraction will be broken because of new attraction of ion dipole attraction. But is it sufficient to break this? No, this one is attraction is larger. The ionic one is very strong. So how it happened? Yes. Here one ionic bond between it Na plus and Cl minus. Right? But here several water molecules round up. So you can't say only one. You can't compare one bond, one ionic dipole attraction and one ionic bond. There are several water molecules round up Na plus and Cl minus. So total ion dipole attraction will be much large. Total, or this total would be large, and total would be comparable or more than that of this. So that's why ionic compounds dissolve. Always you should remember that ionic bond is very much stronger than ion dipole attraction, but large number of ion dipole attractions are formed. So the sum would be very much stronger than this, or equal to that. Okay, stronger or equal. Got it? So that's why if you dissolve small amount of sodium chloride in water, large amount of water, then it will be completely soluble. It will be completely soluble. Why? Sufficient water molecules are there because large number of solvent, large amount of solvent, small amount of sodium chloride. If we add large amount of sodium chloride in small amount of water, then very small portion would be able to dissolve. A very small portion to dissolve, and large portion of sodium chloride will remain insoluble. Why? Number of water molecule is insufficient. Right? Okay. Try to dissolve sodium, large amount of sodium chloride in normal amount of water. Then it will be very difficult to dissolve. Most part of sodium chloride will be insoluble. Okay. Okay. And draw this. Draw this in the gap. There's a gap. Okay. You should note that formation of ion dipole attraction is called hydration. Mark that thing also anywhere. Right? Hydration. Huh?
Water
Yes. Solvation is the common term. And another thing. During this formation, bond formation, what will happen? Energy is released or absorbed. Only during this formation, energy is released or absorbed. Energy is released. Why? Why energy should be released? Because formation, bond formation and bond dissociation, you should remember. To form a bond or to dissociate a bond, Energy should be what? To dissociate a bond, to break a bond. To break a bond, you should give energy. To break a bond. When a bond is formed, it will give out energy. It will give out energy. Okay? Because bond formation is what? It's energetically favorable. Bond formation is energetically favorable. Why bond is formed normally? To attain a stability. Bond is formed to attain a stability. Right? See, chlorine atom is unstable because 7 electron unstable. And bond is formed between two chlorine atoms. See, and Cl2 is formed. That Cl2 is stable because 8 electrons. Chlorine atom 7 electrons. Chlorine in Cl2. Chlorine in Cl2 is stable because of octet 8 electron. So bond formation is normally energetically favorable. That means it gives out energy. It gives out energy. That means exothermic. All this, so process of hydration is what? Exothermic, right?